Hello everyone, I welcome you all to the mathematics class. My name is Gafar Idowu Akonji. The topic which we are going to discuss today is the laws of indices and standard form. Indices is the plural word for index. And what we call an index in mathematics, index number in mathematics, is something of this form. 2 raised to power b, for instance. So the way to pronounce anything written in this form, whose way of putting it down is like this, is what we refer to as an index number. And each of the elements which we have here, I mean the 2 here as well as the b here, has their specific name. This 2 here is referred to as the base, or what we can call the base of the expression. While the number here, the one above here, the superscript here, is what we called power. It can as well be called an index. There are more other names with which this thing is identified, but for the sake of this level, that is, this is JSS2 class, so I am going to limit those naming to either power or an index. And what we want to do in this aspect is, how do we relate with number in this form? Number that happen to be in index form, how do we operate them? That is the whole thing that the indices at this level is trying to talk about, or is trying to illustrate. And one of those things we are interested in is, when I have more than one index number, how is the multiplication carried out? How is the division carried out? Because majorly those are the two main things that we are going to come across at this level, because this is still junior secondary school level. There are also situations whereby we may have to add one index number to another, or situations that may call or that may require for subtracting one index number from another. So without taking too much of our time, we are going to take some example. And before I move on into my example, this 2 raised to power b has a meaning. What it means is that this number, that is the base, this number, the 2 here, should be repeated this number of time. For instance, if I have 2 raised to power 5, the sole meaning of 2 raised to power 5 is this 2 should be repeated 5 times. And the way to solving this is going to say is this: we are going to say that 2 times 2 times 2 times 2 times 2, because the power it has is 5. So this is an instruction or an order that the number which I have, that is my base, will be repeated this number of time. That is, this base should be repeated 5 good times, and which is what is done here. Now if you can go through it one by one, we can see this is 1, 2, 3, 4, 5. And what result is that going to be? So the result is going to give is to multiply all these numbers throughout. So 2 times 2 here gives 4, 4 times 2 here gives 8, 8 times 2 here gives 16, and 16 times 2 here gives 32. So the result of simplifying 2 raised to power 5 is going to be 32. So we are now going to take several examples. Example 1. Simplify the following. A there, I have 10 raised to power 4 multiplied by 10 raised to power 2. B there, x raised to power 2 multiplied by x raised to power 3. C there, 10 raised to power 4 multiplied by 10 raised to power 5. So solutions. Number A there, what I have is 10 raised to power 4 multiplied by 10 raised to power 2. Now this is an instruction that this 10 here should be repeated 4 times. So that is 10 raised to power 4 is going to become 10 times 10 times 10 times 10. Then the result I have here, I will have to multiply it by what I have here. That is, I should multiply my result here by repeating what I have here 2 times. That is times 10 times 10. Now let us check what is the result going to be now. So we can see everything here, everything we're having here is 10. So how many 10 do we have now? We now have 1, 2, 3, 4, 5, 6. So our answer is going to be 10 raised to power 6. It might be necessary at times to give the full result of multiplying 10 in 6 times, and that is going to be 100 million. But we are not interested in that now. What we are interested in is combination of this and this one together. Now that is A part of it. In B part, what I have is x raised to power 2 multiplied by x raised to power 3. Solving this one means I should repeat this number 2 times, I should repeat this number 3 times and combine them together. So doing that becomes x times x for this one times, and here is a call or another that the number here should also be repeated 3 times. So that's going to be x times x times x. Now how many x do we now have in all? The result that gives is our answer. So since we know it is, we want to know the number of x here, so that has to be x. Now let us count how many x in all. 1, 2, 3, 4, 5. So the result here is going to be x raised to power 5. In the C part of the question, I have 10 raised to power 4 multiplied by 10 raised to power 5. So remember what we have to do here is to express this number of times. That is, this number should be repeated 4 times. That is going to be 10 times 10 times 10 times 10 with 10 in 5 places again. So that will be 1, 2, 3, 4 and 5. And how many 10 do we have now? We are going to say we have 10. So the amount of 10 we have is going to serve as its power. So that's going to be 1, 2, 3, 4, 5, 6, 7, 8 and 9. So that is going to be 10 raised to the power of 9. So we shall continue. We'll move over now to example 2. Example 2. So simplify the following. A there, I have x raised to power 5 divided by x raised to power 2. B there, what I have is 10 raised to power 9 divided by 10 raised to power 3. C there, I have p raised to power 6 divided by p raised to power 5. So solution. So in the A part, what we have is x raised to power 5 divided by x raised to power 2. What we are going to do here is we will repeat this base, this x 5 times. We will repeat this x 2 times, and we use them to cut each other. So remember, this sign is the same. This division sign can at the same time make us, we can re-express this thing as, we can write it in this form by saying x raised to power 5 over x raised to power 2. This is the best way we want us to put it. So that is going to become, what is the meaning of x raised to power 5? X raised to power 5 means that this x should be repeated 5 times, and that's going to be x times x times x times x times x. Everything divided by, this one is also another, that this x should be repeated 2 times, and that is going to be x times x. Now the next thing is to cut in order to arrive at the final result. So we see this one will cancel this one will cancel this, and at the end, how many x do I have left? So what I have left is 1, 2, 3. That is x in 3 places. So my answer is going to be x raised to power 3. The next one is number B. What I have there is 10 raised to power 9 divided by 10 raised to power 3. So solution to this has some steps. The first step is that we want to rewrite this thing. That is, we want to re-express it. So the best way to re-express it is to say that 10 raised to power 9 divided by 10 raised to power 3. And what is the meaning of this numerator? What is the meaning of the denominator? So we have to interpret them. What 10 raised to power 9 means is that 10 should be repeated 9 times. And that is going to be 1, 2, 3, 4, 5, 6, 7, 8, 9. 1, 2, 3, 4, 5, 6, 7, 8, 9 divided by, this one means 10 should be repeated 3 times. So 1, 2, 3. Now to get the result now means we should divide. We should allow the numerator to cancel out the denominator. So this will cancel this, this will cancel this, this will cancel this. So to give out the final answer now means we should count how many more x do we, how many more 10 do we have? We have 1, 2, 3, 4, 5, 6. So our answer here is going to be 10 raised to power 6. In number C, we have p raised to power 6 divided by p raised to power 5. So let us remember to rewrite or to re-express what we have here. So when we rewrite it, it's going to become p raised to power 6 over p raised to power 5. So and that becomes the interpretation of what I have here. So p raised to power 6 means p should be written 6 times. 1, 2, 3, 4, 5, 6. Everything over p raised to power 5 here means we should repeat p 5 times. 1, 2, 3, 4, 5. And the final thing now is we are going to divide where possible. This cancel this, this cancel this, this cancel this, this cancel this, and this cancel this. So in this case, we are going to see that what we have left is only 1p. We can say the result is p raised to power 1, which is the same thing as what? Writing p. So this is our final result. So it's either we call this the final answer or we call this one our final answer. In a situation whereby a number has a power of 1, it is allowed mathematically to write that number without inserting the power. So we are going to continue. Example 3. Simplify 3c raised to power 2 multiplied by 2c raised to power 5. So solution to this. So I have 3c raised to power 5 raised to power 2 rather multiplied by 2c raised to power 5. That will become So we can see this is just 3. Why this is c raised to power 2? So this is the same thing as saying 3 times. You can see this one means c should be written 2 times times c times c. So after that we have multiplication sign. So multiply by what I have next is 2. So since this 2 has no power, it means it should be written just once. So that will be 2 multiplied by, so we can see the c here has the power of 5, which means c should be written how many times? 5 times. So we are going to count that now. 1, 2, 3, 4, 5. Now to multiply now means number will multiply number, while the letters will multiply the letter. For that to be done very well, let's first of all rearrange what we have here, so that we have numbers then followed by the letters. So that's going to be 3 times 2 times, let's count the c we have. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. And finally, when we multiply 3 times 2, that gives 6 multiplied by c. So how many c do we have? 1, 2, 3, 4, 5, 6, 7. That is c raised to power 7. So to report the final answer, so it's going to be 6c raised to power 7. And that is the solution to that one. So we still have more examples to take. Now we shift our attention to example 4. Example 4. Simplify the following. A there, x raised to power 6, 4x raised to power 6 divided by 2x raised to power 3. Number B there, 51m raised to power 9 divided by 3m. And number C there, 8 times 10 raised to power 9 over 4 times 10 raised to power 6. So solutions. So in number A, we have 4x raised to power 6 divided by 2x raised to power 3. That is going to be 4, so we have to rewrite it. 4x raised to power 6 over 2x raised to power 3. And that becomes 4 times, remember x raised to power 6 means this x should be written or repeated 6 good times. So 1, 2, 3, 4, 5, 6 divided by 2 times, this is x raised to power 3, which means we should have it 3 times. 1, 2, 3. So we are now going to cut where possible. 2 in 2, 1, 2 in 4, 2. X cancel x, x cancel x, x cancel x. And my result is now 2 times 1, 2, 3 here, x, x, x. We know it's over 1, which is not necessary for me to write. So that now is going to become 2x. How many x do we have now? 1, 2, 3. So the result there is 2x raised to power 3. In number B there, what I have is 51m raised to power 9 divided by 3m. Solution to this has many steps. So the first step is to write what is here. So that's going to be 51m raised to power 9 over 3m, which is the same thing as 51 times m to be repeated 9 times. 1, 2, 3, 4, 5, 6, 7, 8, 9. Everything now over 3 times m. We know there is no count of how many times this m should be written. We can as well just say this is 3 times m, or if you followed what we said above, when we have just m without it having a power, it means its power is 1. That is, such a number should be written only once. So which is what is done there. Then the rest now is to cancel where possible. 3 in 3 here is 1. 3 in 5 here is 1 with the remainder of 2. So when I put the 2 here, making 21. And 3 in 21 gives what? 7. And we can see that this m will cancel the m here. We will now be left with 17 times. How many m do we have left? Let us count. 1, 2, 3, 4, 5, 6, 7, 8. Multiplied by m raised to power 8. Which finally gives the result of what? 17m raised to power 8. In the C part, what we have is 8 times 10 raised to power 9. Everything over 4 times 10 raised to power 6. Now we can see this thing is separated into two forms. Where we have a whole number, the ordinary number not in index form, and numbers that are in index form. So the way to solve this is, ordinary number, we are going to deal with them separately, and the index numbers that we have here are also going to be treated separately. So, and we can see that what we are asked to do in this case is to divide this one by this. So how many 4 can I get in 8? So 4 in 4 gives 1, 4 in 8 gives what? 2. So that will now become 2 times, we can see this is 10 raised to power 9, which means 10 should be repeated 9 times. 1, 2, 3, 4, 5, 6, 7, 8, 9. Everything over. So we can see this number is no more there. So what we have left is just 10 raised to power 6, which is an instruction that this 10 should be repeated 6 times. So 1, 2, 3, 4, 5, 6. Now we can see 10 will cancel out 10. 10 cancel this, cancel this, cancel this, cancel this, cancel this, and this, cancel this. So at the end of the day, we'll be left with 2 times. So how many more 10 are we left with? 1, 2, 3. So that will be multiplied by 10 raised to power 3. And we can say this is the final answer. When we come, the reason why we are going to assume this is our final answer is because when we observe the question given to us very well, the nature of the question is just the nature at which we can leave our answers at times. So we can see the question come in form of an ordinary number multiplied by an index number. So compare it. So it is best we call this our final answer. Now example 5 is something very simple. So I'm asked to simplify x1 a there, x raised to power 0, b there, 25 raised to power 0, c there, 7 raised to power 0. Solution to this: in number a, we have x raised to power 0. Now at this junction, we want to introduce us to one beautiful concept in mathematics. That is the concept of index number, whereby the power is 0. So this is a fact, and the fact just has to be known that way. Any number that has the power of 0 automatically becomes 1. So x raised to power 0 is equal to 1. And this is the solution to A part. In B part as well, what I have is 25 raised to power 0. Remember the fact I stated just now that any number, so whenever the power of any base is 0, such a number automatically changes to what? 1. So our answer here is also 1. What about C? 7 raised to power 0 also has the value of what? It also has the value of 1. Now we have to go ahead because we have to solve as many questions as possible. Now example 6. Example 6 is what we want to solve now. Now we take us to another concept of a negative power. So example 6, simplify the following. A there 1 over 2 raised to power minus 2. B there 3 over 4 raised to power 3 minus 3. C there 2 raised to power minus 3. D there 5 raised to power minus 1. So solutions. Number A, I have 1 over 2 raised to power minus 2. Now it's necessary we explain this concept very well before we delve into solving the question. And the concept is, when we observe all the questions which we've been dealing with so far, we are going to observe that all of those questions always comes with what? A positive power. That is a power that doesn't have a negative sign in front of it. So it is not allowed for an index number mathematically to have a negative power. That is, we discourage having a base with power that is minus. So whenever the power is negative, so it is not allowed. So we just have to get a way of eradicating that negative sign. So I will now use a very simpler approach to explaining it. And the approach is this. Whenever our base carries a negative power, then what we want, what we love, is that such a base must exist as what? As a fractional number. It has to come as a number that is in form of fraction. And when we look at the first question which we are given here, we can see that the power here is negative. So we want the base, the number bearing it, the number carrying this minus 2 on its head. It has to be a fraction. And we can see this question is just like that, because very soon we are going to have a question that doesn't conform with this standard. So once it is not a fraction, so there is a technique by which we are going to change that whole number to what? To a fraction. Now what we want is, whenever our base has a negative power, we want such a base to become what? A fractional number. Now it is a fractional number. Now to eliminate this negative sign is a very simple thing. So what we are going to do now is we just interchange the position of numerator and denominator in this fraction. And that was the reason why I said whenever the power is a negative 1, the base has to be a fractional number, so that a mere changing of position of the numerator and denominator will automatically remove what? The negative sign which we are having there. It's just like the case of when our hands are dirty, be it after we've engaged in some physical activities or some work. Now the next thing that will come to our mind is, how do we get rid of the dirt in our hand? And I'm very sure that washing the hand with soap and water, and at times together with sponge, is the best way to remove such a dirt. We just know that as soon as we are able to use the soap, sponge and water to clean the hand, what we are going to observe is that what? Such a dirt will automatically disappear. So that's exactly what happened in this case. Whenever a base carries a negative power, so such a base must be a fractional number so that ordinary interchanging of the position of numerator and denominator automatically what removes the negative sign there. So let's see how that is going to be solved. So that is going to become, so I don't want negative sign to be here, so to remove it means I will interchange these two positions. So 2 will go up, 1 will come down. Now everything here raised to power 2. So minus is no longer there because we've interchanged the position of numerator as well as the denominator, and that is going to become, now we're now going to interpret this in order to get our result. So getting our result means this 2 over 1 should be what? Repeated 2 times. That is, this 2 over 1 should be written 2 times. And that becomes 2 over 1 times 2 over 1. And we know 2 times 2 is what? 4. And 1 times 1 is what? 1. So that our final result becomes what? 4. In number B, what we have is 3 over 4 raised to power minus 3. Just like I explained above, we hate it when our base has a negative power. So once we see the negative power, that should be the first thing on our mind, that we want to get rid of negative sign. We want to get rid of negative sign. And how do we get rid of negative sign? It's just a mere interchanging of what? The position of this 3 and this 4. 4 will come up and this 3 will come down. So with just that, the negative sign will automatically disappear. So solving it now becomes 4 over 3, then raised to power 3. So we can see the negative sign is no more there. Why? Because we interchange the position of numerator as well as the denominator. Then the rest is to interpret what we have here and get the final result. So that is going to be 4 over 3 times 4 over 3 times 4 over 3. So 4 times 4 is 16. 16 times 4 here gives 64. Over 3 times 3, 9 times 3, 27. So we can leave our answer like this. It's also allowed if we can what? Convert it to what? An index form. Now the next is number C. What I have there is 2 raised to power minus 3. You know, I said it above that whenever the power is a negative number, then the base is allowed to be a what? A fractional number. But look at this number here. We can observe that our base is not fraction. It is rather a whole number. And once it is a whole number, solving it is going to be a problem. So otherwise, what we are going to do is we will force this number to becoming what? A fractional number. We will turn it to a fractional number. How do we turn it to a fractional number? That is just by saying that 2 is the same thing as 2 over 1. So which means when we are given a whole number having a negative power, making such a whole number becoming a fraction is to say that what? The number has the denominator of 1. So and that's going to be 2 over 1. Now everything raised to power minus 3. Now our whole number has been converted, or it has been changed to a fractional number. So once it's a fractional number, it's now very easy for us to eliminate the negative sign. So to eliminate this negative sign here simply means that I have to interchange the position of my numerator as well as the denominator, and that is going to be 1 over 2 raised to power 3. So we can see the negative sign is no longer there, and that becomes 1 over 2 times 1 over 2 times 1 over 2. And we can say our answer is 1 times 1 times 1. That is 1 over 2 times 2, 4 times 2. That is 8. And finally, number D, I have 5 raised to power minus 1. That is going to become 5 over 1 raised to power minus 1, just like I explained above. Now, eliminating my negative sign here means I'm going to interchange the position of 1 as well as 5. So doing that becomes 1 over 5 raised to power 1. And we can see, if we've been following from since, so we're going to see that what this thing means here is that 1 over 5 should be written only once, and our answer here is going to be 1 over 5. So this is where we are going to call it a day on this topic, and in the next video we are going to talk more about our laws of indices. So